This is chapter 5.1, and these are the new examples that we're going to do. Number 6 is about compound interest, and Susan is going to invest $5,000 in a saving account that pay quarterly interest. After 6 years, the money had accumulated to $6,539.96. What was the annual interest rate? So this one is compound interest. So we're going to use the compound interest formula. So for number 6, we have your book say A equal to P 1 plus I and N, right? And I like to expand it a little bit more, which is 1 plus R over N and T. And I'm going to list the things that we know on the side. And if you want to, you can pause the video and see if you can write down the information that you know. And that would be a good practice for you. So if you want to pause the video and come back and check your answer, feel free to do it. And for A, is the amount after T years is going to be $6,539.96, and the principal you put in was $5,000. And the R, interest rate, is something we need to find, right? So we don't know that yet. And N is how many times compounding per years, and it's a quarterly, which is 4 times a year. And T is how many years? We have 6 years. So if this information we can plug into the calculator, plug into the formula. This would be 6,539.96. And equal to P is 5,000. 1 plus, we don't know R, and is 4 times a year for 6 years. So we plug it in and we need to solve for R, right? Because we're trying to solve for R, we want to make this side more simple. So if I can get rid of the 5,000, that would be good. 5,000 is multiplying to this, so the opposite would be what? We need to divide 5,000 to both sides. Okay, so divide 5,000 both sides, 6,539.96 divided by 5,000. And then on this side, you got 5,000 divided by 5,000. And then we have 1 plus R over 4. 4 times 6 is 24, right? Alright, so on this side, this is gone. And it looks like this is not a nice number. So please don't round it until the very last step. So this is going to be a really long number, probably. 6,539.96 divided by 5,000. Actually it stopped somewhere. So let's write that down then. So we have 1.307992 equal to sorry, this is 1 plus R over 4 and 24. So I need to get rid of the 24th power. The opposite of that would be taking 24 root both sides. So 1.307992. This is 1 plus R over 4 and 24. So the exponents and the root will cancel each other. This just equal to 1 plus r over 4. And over here, if we take 24 roots, what you can do is you can rewrite that as an exponent. 307,992 raised to what? This is 1, this is divided by 24, right? So 1 over 24. Do we remember the exponents rule? So if I have this number, I can raise it to parenthesis 1 divided by 24 power, right? Okay, so it's going to be a really long decimal number. I'm going to need to copy the whole thing down because I am not supposed to round it until the very last step, right? Okay, I'm still solving for r, so I need to get rid of the 1. This is adding together, so the opposite would be subtract 1 both sides. So that would be 0.011250025 equal to r divided by 4. So to solve for r, the opposite of dividing by 4 is going to be multiply 4 both sides. So it's like that, and you can cancel, right? So r will equal to whatever that number in my calculator. I subtract 1 and then I multiply by 4, right? So it's going to be 0.04500000 something 997. I don't really need that many places, but I should keep a few because r is rate. So for the rate of interest, I want it to be percentage. So to change the decimal number to become a percent, we need to move 2 decimal places, right? So it will become 4.50%. So that's the interest rate I'm going to need to get the money from $5,000 to $6,539.96 within 4 years if it's compounded quarterly. This is the interest rate. Are we okay with this? Okay, so that's number 6. The next question is number 7. Number 7 asks for the effective interest rate. And if you need to pause the video anytime to write down information, please feel free to do it. So the next question, we're going to look at number 7. So for number 7, it's talking about effective interest rate. And we have special formula for that, right? So this one, Joe need to borrow money. His neighborhood bank charged 8% interest compounded semi-annually. So that's one of the options. And then also there's an internet bank charge 7.9% interest compounded monthly. They want to know which one he can pick to pay less interest. So normally the more time you compound, the interest is going to be higher. So let's try to do number 7 together. So, and for the effective interest rate, and look like this one is compounded several times a year. So we will use this this formula. Your book will say effective rate of interest is 1 plus r over m minus 1. I don't know why they keep changing the letter. So personally, I prefer to write like that. 1 plus r over n and then minus 1, because I like to keep it more consistent with those letters. What do they represent? So let's write down what we know for this one. So if we are using that formula, I have 2 options. One of them is from the neighborhood bank, And what we know from that one is the interest rate is 8%, so R equal to 8%, so we can turn that into 0.08, I'm sorry, 0.08, and then it's going to be compounded semi-annually, so N is semi-annually, which means N equal to 2 times a year. Are we okay? So for this guy, we are going to have R E equal to 1 plus my R is 0.08 over my N is 2, raised to N is 2 here, minus 1. So if I put that into the calculator, I would do 0.08 divided by 2. I'm following the order of operation. So it's basically 1 plus 0.04 raised to second power minus 1. So I add 1, which means 1.04 square minus 1, right? So square that, subtracting 1 is going to be 0.0816, but this is interest rate, so we're going to change it to percentage. 2 decimal places, 8.16%. So this is from the neighborhood bank. And let's do the next one, which is the internet bank. So let's see what we have for the internet bank. So for the internet bank, we have the interest rates is 7.9%, so 0.079 for the decimal, right? And then this is going to be compounded monthly and equal to monthly, which is 12 times a year, right? So using that information, we're going to plug it to that formula again. So R of E equal to 1 plus R is 0.079 divided by N is 12 times a year, raised to 12, subtracting 1. So let's see. 0.079 divided by 12 is this long number, and then need to add 1, right? So add 1 and then raise to 12 power, right? Raise to 12 power. I didn't want to write down because I'm not supposed to round it until the last step, and then I need all the decimal places, and then I need to subtract 1. So the effective rate for this guy should be 0.081924 something, right? And because that's the interest rate, we need to convert that to percentage. So move 2 decimal places. We got 8.19% for the internet bank, right? So which one, if he borrow money, he will pay less interest. If you compare these two, look like the neighborhood bank give him a better deal, right? So we're gonna say Joe will pay less interest with the neighborhood bank. Are we okay with that? Alright, so let's stop here.